Graphs are a way of representing data to show patterns and trends. Graphs help scientists reach conclusions about data. But accurate trends can only be seen if the appropriate graph type is chosen. Learning to choose the appropriate graph type is an important skill. If you consistently follow this step-by-step process, you will choose the correct graph type every time. Recall that most graphs contain a horizontal x-axis and a vertical y-axis. The data on the x-axis determines the graph type. Data goes on the x-axis for one of two reasons. 1. An experiment was conducted with a clear IV and DV. In that case, the IV goes on the x-axis. Or 2. Multiple measurements were taken. The measurements were divided into equal intervals, and the number of measurements falling into each interval was graphed. This is the one time that it is not an IV on the x-axis, but rather the intervals that go on the x-axis. Remember, the IV, or independent variable, is the one that I, the experimenter, change from one trial to the next. The DV, or dependent variable, is the one that's measured and recorded in the data table. It is always a number measured with an instrument. This can be represented with a diagram. Once the data that goes on the x-axis is determined, a second major decision must be made. Is that data qualitative or quantitative? Your lab guide tells you that qualitative data is that which falls into one distinct category or another. There are no in-between options. For example, in an experiment done to measure the average amount of sugar in apples, oranges, and cherries, the x-axis data is types of fruit, and there are 3 choices. There are not fruit options between apples and oranges or oranges and cherries. It is one of the 3 fruits, and that's it. Quantitative data is data measured with instruments with scales marked on them. For instance, a graduated cylinder, rulers, stopwatches, or scales. All DVs are quantitative, but only some IVs are. An example of a quantitative IV would be the height of a ramp for a toy car, because it's measured with a ruler, in an experiment measuring the effect of ramp height on the distance a car travels after leaving the ramp. Now that you've decided which data goes on the x-axis, is that data qualitative or quantitative? The last step is to decide the specific graph type. If the x-axis data is qualitative, then the options are either a bar graph or a circle graph. If the x-axis data is quantitative, then the options are a line graph, a scatter plot, or a histogram. Let's look at 2 examples. Amy drops a tennis ball from a distance of 1 meter, then 2 meters, and then 3 meters above the ground. She measures the average height of its first bounce and records that number in her data table. We are told that Amy is measuring and recording the bounce height in her data table, so that is our dependent variable. The thing that Amy changes between trials is the distance from which she drops the ball, and that is, therefore, the independent variable. Looking at our graphic, we see that we have identified our IV as drop distance, which is measured with a ruler or a meter stick, both of which have a numerical scale. Our IV is therefore quantitative. Next, we see that our IV is specific numbers and not intervals, so a histogram is ruled out. Finally, there is an expected relationship between the drop distance and the bounce height, so the correct choice is a line graph. Let's look at the second example. Mr. Alfaro recorded the number of days he assigned specific students to SAC. He graphed the data for his 3 most frequent offenders, Alvin, Rusty, and Delia. Mr. Alfaro is recording or measuring number of days, so that is the DV. The thing that causes a day to be marked down and recorded is the specific student who earns it. So the students are the IVs. There are no in-between options when it comes to Alvin, Rusty, and Delia, so they are qualitative data. Looking at our graphic, we see that we have identified the IV as 3 students, and that it is qualitative. The number of days is not presented as percentages or parts of a whole, so a circle graph is not the correct option. We're left with a bar graph. By using the method of 1, identifying the data that goes on the x-axis, 2, deciding whether that data is qualitative or quantitative, and finally, deciding which specific graph type in that category is the best fit, you will accustom yourself to methodically arriving at the correct graph choice every time.